These are the check your understanding problems for 5.5, which is finding absolute extrema, for which we use the candidate test. All right, for number 1, it asks at which x value or x values does this function have an absolute max on the interval from -2 to 4. So first thing we're doing is we're finding our critical points, which again is places where our derivative equals 0 or doesn't exist. Our function is a polynomial, so there won't be anywhere where the derivative doesn't exist, but we can find the derivative, so 3x squared minus 6x, and set that equal to 0. And I'm going to divide everything by 3 and also factor out an x. So we have x times x minus 2, so x equals 0 and 2 are our critical points. And then the candidate test says that the absolute max, or absolute min, but in this case we want max, has to occur at a critical point or at an endpoint of a closed interval. So we are going to test values for the original function f at 0, 2, and then also -2 and 4, because those are endpoints of the interval, okay? So plugging 0 back into the original function, we get a 12. Plugging 2, and actually just for simplification, I'm going to factor the first terms here, not because I'm trying to factor the whole thing, but just because this is going to make it easier to evaluate without a calculator. All right, so if I plug 2 into that, I'm going to have 4 times -1, so -4 plus 12 is 8. If I plug -2 in, I get 4 times -5, so -20 plus 12, which is -8. And then if I plug in 4, I have 16 times 1 plus 12, which is positive 28. Again, you don't have to do that, but that just made the evaluating a lot easier because it was factored. Okay, so then of these values, the highest is the 28. Okay, so my answer is that f has an absolute max. Now, here it doesn't say what is the absolute max, but just to be thorough, I'm going to go ahead and say it because it's good to get in the habit of giving it. So it has an absolute max of 28 at x equals 4. I do need to have the at x equals 4 part because the question says at which x values, so it is looking for the input in this case. Okay, pay attention to the question, make sure you're answering the one that gets asked. All right, for the next one, we have a graph of f prime. We have the interval from -7 to 7. It says we have horizontal tangents at -3 and +2 and 5. And there's a vertical tangent at x equals 3, which is right about where that arrow is. Okay. So part A says list the candidates for the absolute max of f of x, and then why is each a candidate. Part B asks for the candidates for the absolute min. Personally, you're never going to see an AP question that splits this into 2. The way that a free response question works on an AP test is basically the scoring comes from, like, one point might be, did you check the critical points? Like, did you find the places where the derivative was 0 or doesn't exist? So like, it might even say like, consider, in this case, considering -3 and 5 and 2 and 3 as possibilities might be a point. And then considering the endpoints, or sometimes they only care about you considering a couple of those. But the idea here is that we just, like, splitting into max and min is a little bit silly, but it's okay for this question because this is, kind of when we're learning it. So candidates for absolute max. Absolute max, we need to consider the endpoint. So -7 and 7, because they are endpoints. And then also, if this is the graph of f prime, I need to consider where this graph equals 0. And that is happening at -5, at -1, and at +5. Whoops. Okay, so I'm going to, all of those are candidates. Now, technically, because in 5.4 we talked about how on a minimum the derivative changes from negative to positive, we can omit the -1. I mean, technically it's a candidate, but we know that it's not going to be one of the possibilities. So if you just want to give the other ones, that's fine. But at least we definitely have to have -5. And I'm actually going to list all of them, -1 and 5. And I'm going to say because f prime equals 0. Okay. There is nowhere that the derivative of f does not exist. Okay. There is a place where f prime does not, the derivative of f prime does not exist, but f prime does exist at that point because I do have a value at 3. So that's a little bit misleading. I'm guessing that this is part of a bigger question that asks for other things, but it's not relevant here. Let's see. And then honestly, the answer to B is going to be the same as A. If you want to specify that, like, we don't need to consider -5 for minimum, for absolute minimum, because the derivative is changing positive to negative, and that's a relative max. We can't have a minimum value at a relative max. You can. Same thing with 5, because the derivative is positive on both sides. But honestly, I think it's better just to say, here are all the possibilities. Let's check every one of them, and then we don't accidentally miss anything. Okay. And then lastly, we have, I'm going to need a calculator for this one. The particle position is given by x of t from 0 to 2 pi, closed interval. Find the time at which the particle is furthest to the left. Okay, furthest to the left means I'm looking for the absolute minimum value of position. Okay, so I'm looking for the absolute min of x of t. Okay, so we're going to find x prime. So x prime of t is e to the negative t times cosine t, and then minus e to the negative t times sine t. I did use the product rule there. And I'm going to set this equal to 0. I'm doing this part by hand, but I'm going to end up using a calculator here in a second. So cosine t minus sine t. E to the negative t can never be 0, so I don't really have to worry about this one. Cosine t is equal to sine t at x equals pi over 4 and 5 pi over 4. I'm pretty sure that came up within the last couple of note sections. Something similar to this. Okay, so those are my places, and meaning my candidates are x of t. My candidates are at pi over 4, 5 pi over 4, and then also my endpoints, 0 and 2 pi. Okay, I'm plugging values back into the original function. I'm going to need a calculator to plug in most of these. I do know that at 0, e to the negative, well, -0 is just 0 times sine of 0. That one's going to be 0. And then this one's also 0 because sine of 2 pi is 0. Hold on, I'm going to get a calculator. Okay, I'm back. So 0.322 is the value of x at pi over 4, and -0.014 is the value at 5 pi over 4. So the absolute minimum is this right here, and the time it happens is at 5 pi over 4. So the particle is furthest to the left, at t equals 5 pi over 4, and I don't think there's a unit on there.